Class 12 Continuity and Differentiability. In the exercise 5.6 we have completed 7 questions. Now we will find the derivative for the 8 parametric functions. X is equal to a into cos t plus log tan t by 2. Y is equals to a sin t. So let us write the first step. Given parametric equations, x is equal to a times cos t plus log tan t by 2, y is equal to a sin t. So these two are the parametric equations. And what is the parameter here? T. T is the parameter. So this function is also dependent on t and this function is also dependent on t. But now we will find the derivative where y is dependent on x. So we know that dy by dx is equal to dy by dt divided by dx by dt. Right? So let us label this as 1, and we know the condition dx by dt is not equal to 0. So now we want dy by dt, dx by dt, which we get by differentiating the parametric equations. So let us first write down x is equal to a into cos t plus log tan t by 2. We will write each and every step here. We want dx by dt, so we have to differentiate. Differentiate both sides with respect to t, which is the parameter. We have dx by dt is equal to d by dt of a into cos t plus log tan t by 2. Now this implies dx by dt is equal to, so here we have constant into function, right? Derivative of constant into function. So we'll write constant and they will differentiate the function. So we'll write the constant and we will differentiate the function. That is cos t plus log tan t by 2. Now this implies dx by dt is equal to a into, now here we have d by dt of function plus function. So we will apply u plus v rule. U plus v, u plus v. So we will get d by dt of cos t plus d by dt of log of tan t by 2. This implies dx by dt is equal to a into derivative of cos t is minus sin t. Since we are differentiating with respect to t, derivative of t will be 1, so which will not write here, plus d by dt of log of tan t by 2. So we know the derivative of log function. So d by dx of log x is equal to 1 by x. So whatever is there after log, it will come in the denominator. So here we will write 1 divided by tan t by 2 into, we should also differentiate tan function, right? So we will write d by dt of tan t by 2. So we differentiated log, we have to differentiate tan. Now this implies dx by dt is equal to a into minus sin t plus 1 by tan t by 2 into, now we will differentiate tan function. So derivative of tan x is secant square x. So we will write secant square, but in the place of x we have t by 2. Now again chain rule, we have to differentiate t by 2, right? So first we differentiated log, next we differentiated tan function, next we differentiated t by 2. So this is what we call chain rule. Now this implies dx by dt is equal to a into minus sin t plus 1 by tan t by 2 secant square t by 2 and derivative of t by 2, here 1 by 2 is constant and derivative of t is 1, right? So this is chain rule. We have applied chain rule to find the derivative. So we know there is a connectivity between secant and tan, right? Tan is sine by cos and secant is 1 by cos. So we will simplify this part here. So this implies dx by dt is equal to a into minus sin t plus 1 divided by sin t by 2 divided by cos t by 2 into secant square can be written as 1 by cos square t by 2 into 1 by 2. Now this implies dx by dt is equal to a into minus sin t plus, so 1 divided by a fraction we have. So when you have 1 divided by a by b, so this will be b by a, right? Complex fraction. So you will get cos t by 2 divided by sin t by 2 into 1 divided by cos square t by 2 into 1 by 2. This implies dx by dt is equal to a into minus sin t plus cos t by 2, 1 cos t by 2 will get cancelled. So you are left with, and we will multiply all these terms. So we will write 2 sin t by 2, 1 cos t by 2 is left over, so we will write cos t by 2. Now this implies dx by dt is equal to a into minus sin t plus, so here we have 2 sin t by 2 into cos t by 2. So we know the formula, sin 2t is 2 theta is equal to 2 sin theta into cos theta, right? So from the half angle formula, so when you have sin 2t, you will write 2 sin t into cos t. Now half angle formula, so when you have just t, you will write 2 sin, the angle will become half, right, into cos t by 2. So here you have 2t, it will become half. Half of 2 is 1, so you'll just get 1. And here if you have 1, it will become half. So half of 1 is half, right? So now entire thing can be replaced by sin t. So we will write 1 by sin t. Now this implies dx by dt is equal to a into we'll take LCM, which is sine t. If you take LCM, you will multiply sine square t plus 1. Now we'll just make a few change here. We'll write 1 minus sine square t divided by sine t. So we have the identity, that is sine square t plus cos square t is equal to 1. So we have 1 minus sine square t. So 1 minus sine square t. So you will remain with cos square t. So this implies dx by dt is equal to a into cos square t divided by sine t. So this is equation 2. So we got dx by dt. Now another parametric equation, y is equal to a sine t. We want dy by dt, so we will differentiate both sides with respect to the parameter independent variable t. We have dy by dt is equal to d by dt into a into sine t. Now this implies dy by dt is equal to, so we have derivative of constant into function. So when we have derivative of constant into function, we will write constant into derivative of the function. So we will write a into d by dt of the function sine t. Now this implies dy by dt is equal to a into derivative of sine t is cos t. So this is 3. So we got dx by dt, dy by dt. So putting 2 and 3 in 1. So this implies dy by dx is equal to, so remember first you have to substitute dy by dt. Since you calculated dx by dt first, so it shouldn't go wrong. So first you have to substitute dy by dt in the numerator. So you will get a cos t, and dx by dt is a cos square t divided by sine t. Now how do we simplify this? So we have studied a complex fraction, right? A divided by b by c. So when you have this form, you will write a into c by b. So a divided by b by c. So you will write a into c divided by b. So in the place of b, we have a cos square t. A by a will become 1. There is 1 cos t in the numerator and cos t into cos t in the denominator. So 1 will get cancelled. So we will get sine t by cos t. And what is sine t by cos t is tan t, right? So therefore the required derivative is tan t. And hence we completed the 8th function.